Isn't the whole point of AMP that it makes my pages fast? Well, yes, but there's more to the story. Here's how to make your AMP pages even faster. Okay, it's true. The AMP library is optimized for speed and all valid AMP pages load fast. But there are additional performance optimizations you can implement to help the browser load AMP pages even faster. Many of these changes are trivial and can significantly improve loading performance without breaking AMP validity. Before we jump in, let's talk about AMP caches. You might have heard or read about the fact that AMP caches do a whole lot of these additional optimizations on top of AMP. And that's true in some cases, such as when AMP pages are surfaced in Google or Bing search results. But there are other cases where they're served from the origin. For instance, when your canonical web pages are built with AMP, such as tasty.co, or when the other platforms without their own caches link to AMP pages on the origin. For example, Twitter started linking to AMP pages if available. This means that if a user clicks a link in one of Twitter's mobile apps, the link goes to the AMP version of your page on your own server. These are scenarios where the AMP cache can't help you with speedy delivery and further aggressive optimizations. Now, the optimizations we can do to an AMP page essentially fall into two categories: optimizations to asset and AMP library loading and server-side rendering of AMP. Let's start with the low-hanging fruit to help the browser load AMP faster. The AMP library needs to be loaded for an AMP-specific element such as AMP image or AMP video to work. This means an AMP image will only start downloading an image once the AMP library has been loaded. This gives us two opportunities to make AMP pages load faster. First, make sure that the browser downloads the AMP library as quickly as possible. Second, tell the browser to start downloading important assets such as images even before the AMP library is available. The key to achieving this is using resource hints, such as rel preload, to prioritize the download of critical resources. For example, even just adding a resource hint in the form of link as script can make a major difference, as the browser now understands that the AMP library is critical to displaying the page and can prioritize its delivery. You'll find many more of these easy wins in the AMP optimization guide on our website, linked in the description. It's also a good idea to take a look at the AMP boilerplate generator, which allows you to quickly generate optimized AMP templates. But as promised, it's possible to take performance optimization one step further with server-side rendering. And the explicit goal here is to improve the so-called first contentful paint, basically the first time something useful appears on the screen. The AMP library comes with a static page layout system to reduce rendering and scrolling jank. The way it works is that the AMP boilerplate code initially hides the document until the AMP library is loaded. Once it's loaded, the library calculates the layout and shows the content. The downside of this approach is that it causes the user to see an empty page until the AMP library is loaded, and it does not support progressive rendering. To offset these negatives, first contentful paint times can be improved by using AMP server-side rendering. This way it's possible to remove the AMP boilerplate so that the AMP document can be laid out and painted without running the AMP library JavaScript. For example, the server-side rendered version of the AMP boilerplate generator renders twice as fast as the normal AMP version. If you want to try out server-side rendering on your AMP pages, I'd suggest to try out the AMP Optimizer, part of a collection of Node.js-based tools we call the AMP Toolbox. Does any of this actually matter, or are these just a bunch of micro-optimizations? My teammate Sebastian has published a blog post where he compared the unoptimized source to the lightly optimized and aggressively optimized with server-side rendering, and the results are pretty clear, with savings between 15 and 55% depending on the use case. Good luck digging through our optimization guide next, and let me know how much faster you made your pages in the comments or on Twitter. Onwards!